Over the years, I've been teaching 126 online. There's been a topic that seems to give students trouble, and it really shouldn't. So there's possibly just some confusion that may be happening. I'm not saying it's easy, but it shouldn't give us that much trouble. So I'm going to create this initial video for frequency and angular velocity. And maybe that might clear things up, because basically, when you're asked to find angular velocity, well, it's represented by the symbol mu. It looks like a W, okay? And basically, all it is the angular velocity is how fast an angle gets generated, how fast the phasor is moving, okay? It's all about your frequency. So your frequency is, how the time it takes to complete a cycle. And so the higher the frequency, the faster it is. So the angular velocity refers to that sine wave, or when we look at it on a grid. But anyway, you're thinking about 360 degrees. So angular velocity is 2 pi times the frequency if we're talking radians. So all you're doing is taking 2 pi times whatever they give you for frequency. That's it. If they say frequency is 500 hertz, then angular velocity is 6.28 times 500. And I just see these missed all the time on a test, and I'm thinking, why are we missing these? So maybe you're reading too much into it, which is possible. Or maybe there's just some confusion. So my angular velocity is 3,140 radians per second. Now, if you're looking for total angle generated, that's a different one, and that's explained on one of the videos as well. Now, if I want to measure in degrees, I take 360 times the frequency. So make sure you are multiplying by either 2 pi for radians or 360 for degrees, and then if you do have prefixes, like for example, let's just say my frequency was 15 kilohertz, then you've got to make this 15,000 hertz. And then your angle generated is 360 times the 15,000. That's going to be a pretty big number, but just to illustrate my point. And that is in degrees. So know the difference between the two. Try not to overcomplicate it. Don't do more than you have to do. And maybe on this next time when I review these tests, nobody will miss this. So that's the deal for angular velocity. The next examples do cover a combo. I looked at them. One covers angular velocity and then mixes in angle generated, okay, which means, how many revolutions did it make given a certain time period. This is how many revolutions it makes per second, etc. Okay, so that's speed. Angular velocity is speed. Angle generated is how many revolutions does it make. So anyway, hopefully maybe this will help a little bit, because I hate to see my students miss these.